we get started. Also make sure you have the tools that we are going to need. Obviously, there are some calculations that we will be doing. So make an effort to have with you, a calculator or some piece of paper where you can note some few things down. Otherwise, we are continuing with the correction for the test that we did. Now, someone asked a question that what are we going to do for next week? And I'm like, next week we are starting a new topic. I would like to think it's going to be appropriate that we move on to a new topic. That is, we have to start studying things of that term. We really don't have that much time. And yes, there is this crisis which has caused this problem here, but we also have to we have to balance, we have to see a way of doing our very best with the limited resources that we have. So next Monday, we will be on a new topic. The corrections will all be done, and I will be recording all of them, and I will also upload them. And in case one or two people have not got the chance to attend the live lessons, you will obviously have to click on the link. Then you follow up, you watch later. In case you have got the chance to follow the whole lesson, you can also still check on it later as part of revising, there is a time when you will need it. So yes, next week we'll be starting new topics, and I guess next week school will be starting, and so you guys will be coming around unless there is something else which is going to affect that. Otherwise, we will get started right away. Today we are doing question 5. We did question 6 last time, so we will do question 5 today. And question 5 will possibly take a whole lesson, and I guess a little bit after that we will. Yeah, so this is the question that we want to deal with. The question that we are dealing with is question 5, and it's on a slide. I just thought I would, let me see if I got this. There is something I thought I would share with you on the issue of the slide, just so you can see it right away. Okay, so there we go. Just check that. All right, so that was it. That's what question 5 is all about. And we can now go into the theory part now that you have seen what this thing is about. So yes, this one is a water slide that we are also investigating, not the whole of it from what you have just seen. We're just taking a section of it, which we can use, to investigate. So they're saying a slide, PQR, right here. You can see for yourself PQR at an amusement park consists of a curved frictionless section, PQ. So there is this section here, which is curved, okay, and it is frictionless, right? And there is another section, QR, which is this one here. And this section, QR, is rough, okay? So it's not frictionless, it's rough. So there is a friction right there. It's also a straight, it's a straight section. It's not curved like the previous section, PQ. This section, QR, is curved. And it is inclined. In other words, it's raised. It's not perfectly horizontal. It's raised, okay? It's raised above the what? Above the ground at an angle what? Of 30 degrees to the horizontal. Now, the starting point P, right here, the starting point P is 3 meters above point Q. So this starting point P is 3 meters above the point Q, okay? Now the straight section QR, this straight section here, QR, is 5 meters long. Now here is someone, a boy, with a mass of 50 kilograms, starting from rest at point P. So this boy was seated at point P and he decided to start sliding down. So he slides down section PQ, then continues down the section QR. So that is the statement, okay, describing what's happening in this case. And the first thing that we are dealing with in this question is a discussion of the solution to the law of conservation of mechanical energy, okay? Now, mechanical energy is purely a combination of kinetic energy and and potential energy. And when we talk of the law of conservation of mechanical energy, we are referring to the conservation. It's like to conserve something is like to retain it, to keep it, to have it there, even if there is a crisis, or even if there is a possibility that it would not have been like that, you see? So when we're talking of the law of conservation of mechanical energy, we are looking at the law which describes what happens to energy. So one thing we know is energy cannot be created. Energy cannot be destroyed. That statement, energy can neither be destroyed nor created. It can only be transformed from one form to the other, okay? So think about having energy of any type, say maybe heat energy. When you want to warm something, prepare some milk or tea, coffee, something like that, the heat generated is converted into the heat of the heat of the coffee you're preparing. So that's the whole thing we are talking about. So we say the law of conservation of mechanical energy states that total mechanical energy of any closed system remains constant, okay? The total mechanical energy of a closed system or in a closed system is conserved or remains constant. So I can get that written down right here. That is question what? Question 5.1. Just make it big enough. So yes, we say the law of conservation of mechanical energy states that the total mechanical energy, okay, that is the total potential and kinetic energy of any closed system. The total mechanical energy any closed system or in a closed system. A closed system can also be used to mean an isolated system, okay? A closed system is an isolated system, a system in which no net force, no net work is done on the system, okay? So in case there is some forces acting on the system, all those forces will balance at the end of the day, okay? So if there is a force of pushing, then there is equal force of pulling just to balance that. So that is what we have. So the total mechanical energy in a closed system is what? Is conserved. So this is what we are talking about. Now, the most important concept here, conserved. Yeah. So you now have to ensure you mention the what? The concept of the total mechanical energy. And the other important thing here is to indicate that it's a closed system, okay? It's a closed system. And the other thing here is it is also conserved. So we can either talk of a closed system or an isolated system. So you might find in some material, instead of using closed system, they're using what? Isolated material. Sorry, isolated system. Like that. Is conserved or remains the same or is constant. You see, those are some of the words used. That means it does not change. The total energy does not change, it remains the same, but the energy can change from one form to the other, okay? The energy can change from one form to the other, but the actual value of the energy, you know, does not increase and it does not decrease. So you have light energy changing into what? Into heat. You have heat energy changing into what? Into light. You have sound energy changing into what? Into electrical signal. You know, just like when you go to a hospital and they're checking your heartbeat. So each time the heart is pumping out blood, the energy given out there, that energy of vibration gets converted into the what? Into the electrical signal. It's not lost. And that is what we call the total, rather the law of conservation of mechanical energy. The statement is the total mechanical energy in a closed system is conserved or remains constant. So these are some of the important points you have to include in your what? In your statement. It's not something that you are defining or describing. You are stating a law. So the next thing here is to look at the next question, which is question 5.2. So question 5.2 is asking for the speed, okay? The speed of the learner at point Q. So let's check this out. So the learner started right from point P and he slid down all the way up to point Q. And he is not stopping at point Q, okay? He is continuing from point Q to point R. But the question is asking us specifically to determine the speed, okay? The speed of this person at point Q. Now, the interesting thing is the law which we have just stated. The law we stated is that the total mechanical energy of this system will not change. Very much like saying the energy that this person was having at the point P will be the same as the energy that the person is having at the point Q. So specifically, we want to ignore frictional force since this section here is what? Is smooth. And because we are ignoring frictional force, and it is like a closed system for this case, we would like to think that the total energy at this point P, or the total mechanical energy, which we would like to talk of as mechanical energy, rather as kinetic energy and potential energy, those values at this point must add up to give the same mechanical energy at this point. So yes, it is possible that at this point, one of the two, potential energy may have a different value as kinetic energy at point P. But when they add together, they must give us the same value that we would get when we add the potential energy and the what? And the kinetic energy at point Q. So the formula, or rather the statement of the conservation of mechanical energy will now be put into what? Will now be put into a mathematical expression to help us determine the speed of the learner at point Q. So we will be like, the total mechanical energy at point P must be equals to the total mechanical energy at point Q. You see that? So that is what we are going to be dealing with. And the mechanical energy at point P. Okay, so let's just have that written down right here. So it would be like the mechanical energy at point, just use this since it's already there. So we say the mechanical energy, oh, unfortunately it's not accepting. So there we go. We say the mechanical energy at P must be equals to what? Must be equals to the mechanical energy at Q. So we say must be equals to the mechanical energy at Q. That is from the principle of conservation of what? Of mechanical energy. And because of that, we now need to determine the mechanical energy at what? The mechanical energy at P. That is going to be the potential energy and the kinetic energy. Okay, so we are going to be having kinetic energy and potential energy. So kinetic energy will be what? Will be half mv squared. Just reduce this size just a little bit so that it will appear on its, on its online like that. Just want to have it like that, yeah. So there we go. Now we are looking at the mechanical energy at point P. Well, point P is this point here, this one here. So the mechanical energy will be the what? The combination of kinetic and potential energy. So let's have that right away. So we'll be having potential energy Sm, okay, Smgh, and the kinetic energy, that is potential energy, Smgs, and the kinetic energy is what? mv squared divided by 2, or half mv squared. All right, so let's have this mv squared divided by 2. So we would like to write this mv squared divided by what? By 2. So this is the what? This is the total mechanical energy at the point P. So let's put it inside the bracket. And we say this is the what? This is the, not here. So this is the mechanical energy at point P. Like that. So now it must be equals to what? To the mechanical energy at point, the mechanical energy at point Q. So we'll be having mechanical energy at point Q being the sum of mgh, okay, for potential energy, and half mv squared, which is mv squared divided by 2, right here, mv squared divided by 2. So yes, this is the mechanical energy at point what? At point Q. Put it inside bracket. Then next thing is to indicate that it's at point what? At point Q. So yes, basically what we have here is the mathematical expression of the principal conservation of mechanical energy, which we just stated in what? In 5.1. So the next thing now that we want to deal with is the substitution. Now, when we look at this diagram that we are dealing with in the first case, the slide, we notice that at point P, this learner here is starting at rest, meaning initially at point P, he's not having any velocity, he's not moving. And because he's not moving, the velocity is 0. He's at rest, okay? He's starting from rest. Right here, it's been indicated. He's starting from rest at point P. And so because he's starting from rest at point P, we put 0 for what? We put 0 for the velocity. So at point P, velocity is going to be 0. The mass was given as 50 grams. G is a constant value, which we can do what? Which we can determine. So the mass right away will now be 5 that we have to multiply with G. And what's the value of G? The value of G is 9,8. Okay, then the value of H was given as 3. Now this one must then be done what? Must be added to the mass. Okay, well, let's first have it, the whole of it like this. So this is being divided by 2, and the mass is still 5 times the velocity, okay? The velocity squared. And what's the value for the velocity? Well, unfortunately, the value for the velocity is 0 and squared. So that's what we are going to be having where? On the right-hand side, rather left-hand side. Then on the right-hand side, we will be having, well, now notice that at point Q, which is right here, at point Q, the distance of 3 meters will have reduced to 0. Okay, because 3 meters was the distance above the point Q. So at point Q, this 3 meters will now be 0. Okay, because he's sliding down like this. So the height above Q keeps on what? Decreasing until this learner reaches point Q. And because of that, we substitute what? We substitute 0 for H. So we'll be having 5 times what? 5 times 9,8. Then times what? 0. Plus mv squared, which is m is 5. Oh, okay. Let me just reduce the font a little bit. Just reduce this so that they can fit on one line. Okay, yeah, that's enough for us. So we'll be having here 2 as the denominator, and the mass is 5, and the velocity, okay, that is times velocity. We have it here, times v. What's the velocity? Well, interestingly, the velocity is what we are looking for. So we don't have the value for b. That's what we are looking for. That's what we are supposed to calculate. So what will that lead us to? Well, this is going to lead us to 5 times 9,8. Now that requires a calculator. So in case you do have one with you over there, this is the time to put it into what? Into some serious tasks. So we are going to multiply 5 by 9,8. Then by what? By 3. And that will give us a value of 147, okay? So we are going to have 147. Then this value of 147, we will add it to nothing, okay? The whole of this will cancel to 0. This quantity here will cancel to 0 because of this one here. Then on the right-hand side, the first quantity will simplify to what? To 0, which is 5 times 9,8 times that. Then this one here will stay the way it is as 5v squared over 2. Okay, so we'll be having what? 5v squared over 2 right away and right here. So this is 5v squared. So next thing here is to determine the value of v. How do we do that? Well, we just have to cross multiply. you know, now this one, we can ignore it. We are dealing with this on the right-hand side, and this other quantity on the left-hand side. And so we can then cross multiply. In other words, on the left-hand side, we are now having 147. And on the right-hand side, we have got what? 5v squared divided by 2. That is 5v squared, which is being divided by 2. So what we do at this point is to cross multiply. Now, it's a lot easier to cross multiply when we place 147 over what? Over 1. So that we can multiply 2 by 147, then 1 by 5v squared. So what is that going to give us? Well, this is going to give us the value of well, 249 for 2 times 147, then 5v squared on the other side. 5v what? 5v squared. Like that. So in the next step, we want to make v squared the subject. So we divide what? We divide both sides by what? By 5. That will give us 249 divided by what? Divided by 5. So that we are left with what? V squared on one side. Then on this other side, we are going to be left with 5v squared divided by 5, okay? So this is what we are going to be having. 5v squared divided by 5. We're just looking for a way of isolating v, and that way we can determine the what? The value we are looking for, which is the value of the what? Of the speed. So now from here, the next thing we want to deal with is to find the value of 249 by what? By 5, when divided by 5, which gives 58.8. So we write 58,8 equals to what? To v squared. That's what we got so far. So to find the value of v squared, well, check with your calculator there. Yeah, sure. Thanks for this. I got some response on this. So what have you got for 58.8? Let's check if you're doing a calculation there. You know, you can do the calculation and pass over the value to me. I want to check that you're following. So what do we have for the value of v? Can someone send me a message on that? Yes, what can we get for the value of v? V is going to be the square root of 58,8. So, I've got a message here, 58,8, S7, what? 6, 7. Yeah, so that's the value of v, 7,67. In what? In meter per second. Unfortunately, I can't hear you. Someone is trying to speak, but I can't hear you. Just send a text, okay? Just write. Just send a text in the chat box, and I check it from there, because looks like the internet is weak over that side. But if you can hear me, it's fine. Okay. All right. Yes, let's go. You got a question, right? Can you just type it, or you can say it? If your internet is fine, just say it out.
Okay, so can you hear me now?
Yes.
Okay, so my question is, I don't understand why you chose to use the 5 meters value. the distance between Q and R instead of 50 kilogram, the mass of a learner, when you're substituting the.
Oh, all right. Wait. I guess I just. Oh, sorry. Look, I missed this out. I did not see it nicely. I did not use these 5 meters. In fact, I was substituting the 50, but I missed it. I thought they had written 5. Thanks for that. Let me put it right away here. This is supposed to be 50, not 5. So we have here 50, and also here 50. Okay. Over here we have 50, and this side here we have 50. Okay, and that would give us also 50 for this. Well, the good news is we have seen this before concluding. Yeah, it's always good to check through. So 50 here is the mass, 50 here, 50 here, 50 there, and 50 this side. So now when we put a 50 here, this one will be having a 0 over there, right? Yes. And also here we'll be having a 0, and here we'll be having a 0. Okay, then that way we will be having what? I guess a 0 here, and also a 0 there, then a 0 here, a 0 there, a 0 here, a 0 there. Okay, yeah, so that is what we have done. And check what do you then get when you divide 2490 by 50? What do you get over there? You got a calculator? Yeah, someone has sent here. Okay, we get 49.8, really? Then let's check. 40, we get 49.8. Okay, then what do we then get when we get the square root of the answer? Is there something we can? Looks like, well, let's see. This 0 that we needed to add, I hope it has not caused us any more problem. Yeah, the thing here is we have put here 50 now, 50, 50. So this step, there is no problem. And also here, let me just check really quick. I'm just going to check with the calculator I'm having here. So 50 times 9,8, okay, then times what? Times 3. Yes, it will give us this value, which is correct, just like this one here. And this is what we are going to be having. Now, the thing is when we multiply 2 times that, okay, let's now see what we get. Times 2. Yeah, times 2, we get 2,000. Okay. This value will change. When we multiply 2,470 by 2, the value will change to 2,940. Okay, that's what is going to change. And now that is what we are going to substitute here. That is 2,940. So this way, we can go ahead to do what? We can go ahead now to divide it by 50. So now when we divide this by 50, we get this same exact value. Okay, you can just check that out. All right, yeah, I get it. So now there was an issue that we needed to fix. The 50 is the right value to put. So after putting it, it would change this to 2,900 and what? And 40. And now when we divide 2,940 by 50, this is what we get for the value of v squared. And so we can get the value of v after getting the square root of what? Of 58,8, and that gives us the value of 7,67 meters every 1 second. Yes, this is the solution to question what? To question 5.2. So you guys got a question, you can just type it down in the chat box and I check it out. Otherwise, if there is no question, we can then move on to the next part of the question, which is what? Which is 5.3. So 5.3 is requiring us to, 5.3 is requiring us to do what? To draw a labeled free body diagram. For what? For the boy while he is on the section QR. Okay, so now notice that we are done with the section P to Q. The section we are dealing with at this time is the section Q to section R. Well, the section Q to section R was indicated previously in the statement here that it is a section which is straight. That is one, it is not curved like this one. This is a curved section, but the section QR is straight. The second thing is the section QR measures what? 5 meters. And the other thing is the section QR is also rough. So it is rough, straight, and inclined at what? Inclined at 30 degrees. So we can take this rough and straight and include it in our what? In our description of the free body diagram. So how will the free body diagram look in this case? How do we draw that? Well, let me just use this for drawing. Okay, so there we go. I'm going to, do this. Okay, let's say this is the platform, okay? And because that is the platform, then now this is the base. So the 30 degree is right down here. So this person we are talking about is, okay, the person we are talking about is very much like over here. Yeah, it's like he's over there, you know, something like that. So if we are to make a free body diagram for this person, well, just make this a little bit big. Okay. So if this is the person we are talking about right over there, then we can think of him as exerting some force on this platform here, and the forces or the force being exerted there, or the forces being exerted there, there are a number of them. They include what? They include the normal force, okay, which is going to be normal or at 90 degrees to this platform. Then they will also include the what? They will also include the component of the weight right down here, if you like it. And we'll also talk about the weight, okay? Right down here, you see? Now it has become too much. So let me just clear that out and we do a nice small one. So the person we are talking about is right over here. Okay. Now he is sliding down, and since he is sliding down and the surface is rough, that means there is frictional force acting on him, and the frictional force acting on him will be acting in which direction? In the direction opposite to the direction of what? To the direction of motion of this same person. So you see, this is the direction of frictional force. Then he is on this surface here, and so he's exerting a normal force, which we can illustrate like that. So this is the normal force, which is acting on what? On this person. And again, he has got weight, and so this is the weight acting on him. You see? So in total, we can then have what? We can now have the normal force right here. The normal force is right there. Then we have the frictional force right here. You could call it FF, the frictional force. Then we have the what? We have the weight of the person right down here. These are the forces acting on this person. Now, you could also think of indicating the component of the weight, but it's not now that necessary. The component of the weight is not necessary, given the fact that we already indicated the weight, okay? But obviously, the component of the weight, one is in this direction, and another component of the weight is in this other direction, okay? The one which is what? Balancing the normal force. So this is how you would illustrate the what? The free body diagram. And that is the solution to the other question, which is question 5.3. Yes, this is 5.3. Now, let me just get this right away. Let me first get our solution. And we put it onto the page where we are answering, okay? So this is our solution for the free body diagram. And we put it right away where it's supposed to belong, right over here. We are talking about 5.3. And the solution is this. Oh, unfortunately, it has refused to paste. So yeah, we will be looking at it from here. There isn't a problem. We will be looking for it, rather looking at it from here. So the next thing now that we want to deal with is the next question, which is about, well, 5.4. They are saying the coefficient of friction, okay, the coefficient of friction between the body and the surface is given as what? Is given as 0.08. Okay, so this is the coefficient of kinetic friction. So how are we going to handle this? Well, that piece of information, we can put it down. So we say the coefficient of kinetic friction. Do we have a representation of that? Yeah, we can have it right here. The coefficient of kinetic friction right here. Coefficient of kinetic friction is given as 0.08. So with that piece of information, what are we supposed to do? We are supposed to calculate the magnitude of the kinetic frictional force acting on the learner when the learner is on section QR. Okay, the magnitude of the kinetic frictional force on the learner when the learner is on the section QR. So how do we handle this? How do we calculate the kinetic frictional force? Well, one thing we know is kinetic frictional force is directly proportional to the normal what? To the normal force. You see, this is what I was talking about. So now here, if we are to straighten this, okay, if we are to make this extend up to the other side, yeah, something like this. Okay, kind of like that. Okay. So here, now what we have down here, okay, what we have down here is the component of the what? Is the component of the weight. The weight is W here. The component is here. Well, now this thing of the component might be disturbing you a little bit. Let me first straighten this. Let me make this long enough so that you can see really nice what we are talking about. Okay, because I noticed a lot of you guys had difficulty solving this part here. So now let me draw a straight line right away like this. Okay, So you see, now the interesting thing here is this angle here in the middle has been given for us as what? It has been given as 30. So we have that angle as 30 degrees right here. You see? And now with this 30, we can get the component of this weight. We can get the component of this weight along this line here. And the component of the weight along this line is W sine of 30. Now the component of the weight along this other perpendicular section is W cos of 30. You see that? So this section here gives us W, which is the weight, and the weight can be written as W or S mass times what? Times acceleration due to gravity. But this time it's a component, so it's not only W, but it is W cos of what? Cos of 30, which is the cos of the angle there. And so we can write it also as what? As mg cos of 30, like that. Why are we doing that? Is because we are looking at the component. You know, we are looking at the component of the weight, because the weight here, as you can see, the weight here is W, but there is a component of the weight here. We are dealing with the component of the weight because frictional force directly is balanced. You know, the force which is balancing the normal force is now this component here. And the formula we have to deal with is this formula here, that frictional force, if we use FF as an example, like this, frictional force is directly proportional to the normal force. And so we can write frictional force. In fact, let's just write this, maybe F, just that. Frictional force is what? Equals to the coefficient like this, K. Let's put it there. And what? And the normal force. You see? So that's what we are dealing with. That is what we have right now. And that is what we have to deal with so that we can substitute. So this is the formula we are talking about. Now, the thing here is frictional force increases with increase in normal force. Okay? In other words, frictional force increases with, for example, with weight, because traditionally weight balances the normal force if there is no inclination. Okay? So frictional force is directly proportional to the normal force. And the normal force, Fn, in this case, is this one here. But the force which is balancing the normal force is the component of the weight, but it is not the weight. Okay, it would have been the weight if there was no inclination. If this one here was right down on the horizontal ground. But now because this is raised, the weight comes down here and we are dealing with the component of what? The component of the frictional, rather the component of the weight. And so this component of the weight is what is balancing the normal force. And because of that, because of this, we will then be having the component, rather the normal force represented by the component of the weight. And that is where a lot of you went wrong, because I noticed that you were substituting, instead of Fn taking the value of the component, you were substituting W for this one. Now that would have been correct if you were dealing with what? Without any inclination. But since we have this angle of inclination of 30 degrees, we have to deal with the component, because as you can see, it is Fn being balanced by this. Weight is not the one balancing Fn at this time. And so right away into the substitution box, we will then be having what? The frictional force equals to that. And we are supposed to calculate it. Well, let's just call it Fk. You know, there isn't any problem with that. Just put it, the kinetic frictional force, like that. So do we know this? We do, it's right here. Do we know Fn? Yeah, we do. Fn is what? Is the component of the weight. is the component of the weight perpendicular to that plane. So right away, we substitute. And when we substitute, what do we get? We get Fk. That is Fk for the kinetic frictional force equals to what? Equals to 0.08 times the normal force, okay? And what's the normal force in this case? The normal force in this case is the component right here, mg cos of 30. So let's have that right away. Do you know m? We are dealing with the same value of m, which is 50. Do we know g? G is the value of acceleration due to gravity, which is 9.8. Do we know cos of 30? Yeah, that's the next quantity to include. So we have cos of what? Cos of 30. And that is going to be the value of the kinetic frictional force. So let's do that right away. We then say the kinetic frictional force, Fk, equals to what? Yeah, someone get for me that value? You got a calculator with you over there? You have to multiply what? 0.08 by 50, then by 9.8, then by cos of 30. What do you get for that? Just do that really quick and send me the value in the chat box. Is it coming out? Yes, someone has sent a value right here as 33.95. 33.95, and that is also the value which I have got. So yes, this is 33.95. This is the value of the frictional force. All right, so that's how you would determine the value of the what? Of the kinetic frictional force. So I again repeat, much as the original formula is kinetic frictional force equals to the coefficient, okay, times the normal force. If there is an inclination, then the normal force, okay, if there is an inclination like this, then the normal force is the component of the what? Is the component of the weight, which is perpendicular to the what? To the plane, or perpendicular to the what? To this surface here. And so because of that, this is what we take. Any questions so far? All right, so if there is no question, then I guess we have got to be concluding with the last question. The last question is asking for our use of principle of conservation of energy, okay? The principle of conservation of energy to do what? To calculate the speed of the learner at the point R, okay? The speed of the learner at the point R. So now, to make things a little bit easier, we are going to investigate separately R to Q. We will not include, just like the way we never included it when we were calculating these other previous questions. We are going to deal with QR separately, and dealing with the QR separately means we have now to investigate the motion of this person from the point Q to point R. And how do we do that? We also use the principle of what? The principle of conservation, or rather the energy principle. And the energy principle in this case, right away, just write it really quick so that we conclude this. This is question 5.2. And just see question 5.5. Yes, question 5.5. So 5.5, the principle of conservation of energy. This time we are going to include the element of what? The element of work done in this case. So it will be like, well, the whole principle of energy will be W, that is the net work done, W over there, N, that's the principle of what? The principle of energy in this case, equals to what? The change in potential energy and the change in kinetic energy. So this is what we are going to be having, the change in potential energy, which is going to be EP. EP, that is the change in what? Potential energy, which we are going to add to the what? To the change in kinetic energy. That is change in kinetic energy, E what? EK. Yeah, like that. So the next thing now we want to investigate is we will have to talk about the kinetic energy at this point. Okay, kinetic energy at this point and kinetic energy at the other point. Then also potential energy at this point and what? And also potential energy at what? This other point here. Okay, so that is the thing we want to deal with. So how is that going to be? Well, to determine that, we will have to put the formula nicely. So it will be for the network done, okay? For the network done, we will use our same formula of force, which in this case is F, times the distance, which is what? Which is delta X, times what? Times cos of theta. We got theta here. Yeah. Now this is going to be equals to what? The change in potential energy. All right, let's just write it as mgh, mgh. Now notice that the change in potential energy, just here's the diagram. We are dealing with the calculation from point what? Point Q to point R. Now the change in potential energy is going to be majorly due to the change in height, okay? Like at this point and this other point here. Do we know the height at this point? Well, if this is the ground or the reference point, then the height at this point is 0, okay? Then the other thing we have now to deal with is what is the height at this point here, okay? Is there a way we can find the height at this point? Well, we can find the height at this point since we know the what? Since we know the length of this plane here. We can use the component sine theta, okay? Sine of this angle equals to the opposite, which is this length here, divided by the hypotenuse, okay? So let me just put that down so that is easy for you to check through. We are talking about the height, so let me first not put that. There is some rough work here which we need to put down. So the height in this case that we are going to be talking with the next height, or let's just call it the change in height, is going to be delta H. All right, sorry. Right here. Okay, so this is what we are talking about. We want to deal with the change in height, delta H, which is what we are going to be substituting there. We are going to be substituting this value right over there as delta H, because the change in potential energy is going to be simply due to the change in height, okay? This is not a new formula. This one we have just included the delta H because there is going to be a change in height, and change in potential energy is merely due to the change in height, okay? It's majorly due to the change in height. And so the change in height is going to be the final height, okay? It's going to be the final height, which is at point R0, minus the initial height, okay? Which is due to this point here. And the initial height is this other one here, okay? So this height, as I was indicating, we are going to use the sine relationship, which is what? Sine of this angle equals to the height, which is opposite, divided by the hypotenuse. And so to define this height here, we have to multiply this 5 times the sine of what? Times the sine of 30. That is what we are going to get here right away. So this one would be 0. In fact, if we are to substitute it right away there, we will be having 0 as the final height, and the initial height there is what? Is 5 times the sine of what? Times the sine of 30. Then we now want to investigate what? We now want to talk about the change in kinetic energy. Now notice that the change in kinetic energy that we are going to investigate, the kinetic energy is only going to change because of the change in the velocity. So we'll now have to look at the velocity at this point and what? And the velocity at this other point here. And now the velocity at this point R is what they're asking for. Check here. We are supposed to calculate the speed of the learner at point R. So the speed of the learner at point Q is what we calculated initially. And what's that value? Well, that value is right here. It's this one here. So the speed or the change in kinetic energy, it's going to be, just put this, mv squared divided by 2, or simply have mv squared. So 2 here, then m times v squared, okay? M times v squared, like that. But as I indicated, the change in kinetic energy is purely due to what? Due to the change in the velocity. And so we can now factor this out. We can factor this out and we put it like this. We put the v right out there so that we can deal with it without any problem. And we can put it inside bracket. No problem with that. Can put it inside bracket. mv squared, okay? mv squared. So the final v minus the initial v, we would like to call it vf squared. So let's put this vf squared. This is going to be the final v squared. Then the initial v is what we had already calculated, and we got the value of 7,67. It's right here in case you can't remember it well. It's this value here, which we have substituted right there. So let me just reduce the size of this a little bit so that it will appear on the same line. So just reducing this a little bit. So that it will be on one line, like that. Yes. So that is what we have. Now here, the force we are dealing with is the frictional force, and here we have the distance, and we have the what? The cos. Cos of what? Cos of 30. So let's just substitute and we get all the values as required. So do we have the value of the frictional force? I guess we do. It's 33.95 in what? In newtons. Let me just indicate that. So we have this 33.95. Okay, times the distance. And so what's the distance? Do we have the distance? Yeah, we do. We have the distance as S5. Then now, the direction here. The direction of frictional force. The direction of frictional force, unfortunately, is the exact opposite. You see, frictional force is here. Okay, so the person is sliding down here, and this is what we are dealing with, the frictional force right up there. So the direction is in this other direction while the person is moving this way. So instead of having the direction in this way, we would have the exact opposite, which is what? Which is 180 compared to the direction of motion. So right away, we'll be putting that down as what? Cos of 180. Then we make this equals to what? We have the mass, right? The mass is 50. We had it before. And the value of G is 9,8. Then the rest of the thing is just the calculation. So what is this one? This is minus 5 sine 30. Just put it minus 5 sine 30. 5 sine 30. Then this one, we just simplify it to plus. The 50 divided by 2 is 25. Okay, this is 25 for 50 divided by 2 times what? V squared minus this. All right, let's put it as V squared minus 7, so have your calculator with you so that we finish this calculation really quick. So this is squared and this is what? This is F. So have your calculator with you and get for me the quantity on the left-hand side, then send the quantity on the left-hand side, okay? This is 7,67. Yes, so what is the quantity on the left-hand side equals to, when simplified? That is 33,95 times 5, then times what? Just reduce this a little bit so that they can, yeah, get on one line. Yeah, this is much better now. So please do that and let's see what you're going to get from there. You're multiplying 33,95 by what? By 5, then by cos of 180. Cos of 180 is what? Is the exact opposite of cos of 0. So what will that value be? What have you got? Yeah, so we have got a response here. The value is, yes, negative 169,75. So that's what we have on the left-hand side. So let's put that down here. Negative 100 and what? 69,75. Then on the right-hand side, we are going to be having this quantity. So what is it for this? This is 50 times 9,8, then times what? Minus 5 sine 30. What is that value? 50. Okay, you will multiply 50 by 9,8. Okay, then later by what? By 5, by again sine of 30. Remember to include the minus and see what you get from that. Okay, what have you got? Yeah, here we are seeing a response. It's 1,225. Yeah, this is a good one. So we substitute it right here, 1,225. Only that it's negative. We put the minus there. Then we'll now be having plus what? 25v squared. 25v squared, and also multiply the next quantity, and we see, while I'm putting this v squared here, see this equation thing comes with a lot of, so multiply 25 by 7,67 and see what we get. Yes, what have you got for that? Okay, I'm getting a response here. This is 25. What have you got? This is, you have to multiply then now 25 by 7, what? 7,67. Yeah, I'm seeing a direct message here. This is 191. This is what someone has got, 171, what? 75. So yes, we are now breaking things down. We are simplifying things. So let's just add all these quantities. So we transfer everything, this, and that is this one, this to the other side. And let's see what we get. So what is it going to be when we do that? Still, we will need to use our calculator. So this is negative of 169, okay, 75. This value, we have to add it, okay, because now we are taking this one, which was negative here, to the left hand side, so it becomes positive. So this is 122, what? 5. Then again, we have to add this at the last quantity, so we say plus 191, okay, 191,75 right away. So this in total will give us the quantity on the left hand side as what? As 1,247. Then on the right hand side, we are left with the 25, okay, 25 VF squared. So since we are looking for the value of VF squared first, before we find the value of VF, the next thing we want to deal with is going to be to find the value of VF squared. We do that by dividing what? By dividing 1,247 by 25. So what is that going to be? Well, let's see. 1,247 divided by 25. Okay, divided by 25. This is going to be 49.88. 49,88 is what we are going to be having on the left hand side, and on the right hand side we now have what? VF squared. Someone get me the square root of 49,88 so that we can finally get the value of VF squared. That's what we are looking for anyway. So what's going to be the value of VF squared? It's going to be the square root of 49,88. So yeah, the square root right away is going to be, that is the square root of 49,88. Yeah, I've seen it here. Yeah, it's 7,06, yes, 7,06. So yes, this was a fairly long question, but this is the last bit of it. So 7,06 is the value of the velocity or the speed with which this learner is going to reach down that point R, okay? So in meters per second, okay? This is the value for the speed. And yes, that leads us to the end of the discussion. Let me just check if there is a question. This is VF. Put it like this as VF. So anyone with a question on this? So this was the last bit of the question. It's question what? It's question So any question? Can we just check one or two things here? Let's see what we have got here. This is the, we can check this just to be sure. When we multiply this 50, this is this and this is that, we get this value here. And this is 25, it is 25 because we divided what? 50 by 2, and when we divide 50 by 2, what we get is 25. This 25 multiplies that and the other quantity, and we get this. So we transfer this and the other, all this other side, okay? Or the final answer, okay. Yeah, someone has got a different final answer, which is 8,72. 8,72, okay. 8,72. Let's first put it down. 8,72. All right. Now, there is this discrepancy in the answer. So you know what we are going to do? We are just going to check our calculation really quick, okay? Let's check the calculation really quick and we see if there is something that we did not do well. So I'm going to use the calculator, which I have right here with me, and I see what that is going to give. So starting with this calculation first, we start with this, and it's what? 33,95 that we have to multiply with 5, and then we will also have to multiply it with what? With the cos of 180. Cos of 180. Yes, this is 169,75. This is correct. Then now we check with this next one here, which is what? We now check this just to avoid the what? The discrepancy, which is coming in the final answer. So we'll be having 50 times 9,8, okay? Then again times what? Times the minus or the negative of 5, the negative of 5 sine of 30. Okay, we close that. So it will give us this value. Well, this one is still correct, okay? Then what we get here for this one, this is going to be 25 times that is 25. So let's just check this last value, if it's going to be true. So the last value there is 25, which was 50 divided by 2, okay? 25 times what? Times 7,67. Yeah, it's 191. Okay, so these values are correct. So now when we add these two, the next thing now we want to check is this one here. So we will start with the minus of 169,75. Okay, to that we are adding this and the other. So let's add 1,225 to 191,75. We get 1,247 equals to that. Oh, okay, so there seems to be no discrepancy. So this value, then we now divide it by 25 and we get this value. Then now the next thing is to find the square root of this. Okay, so we have to find the square root of 49,88, which is 7,06. So there seems not to be some obvious thing. Oh, okay. Yeah, there is a suggestion here. The initial velocity wasn't squared. Oh, let's check that out. Oh, yes, it's this one here. That is where we were having issues. This was supposed to be squared. Yeah, this is a good thing. Yeah, we were supposed to square this. Yeah, that is just the thing with the typing error. So, and you see when we now square this, the whole thing will change. Yeah, that's a good thing to have checked it out. So let's square 7,67, and we see what we get. 7,67 squared. This gives 58.83. Okay, so you see this one only when squared will now be, yeah, we squared it from here, but we just did not square it from here. All right, so this is 58,83. Yeah, this is going to be the last thing we needed to check. And so it will only affect this value here. So we multiply that by what? We multiply that by 25 so that we can see what we get. So we'll be having 58,83 by 25. We get 1,470,75. Yeah, that's what we get. That means this value will change. And so we then now be having the minus of 169, comma what? 75. Then we have to add this to 1,225. Then later we also add it to 1,470,75, like that. Yeah, so this will give us a new value, which is what? 2,526. So the next thing for us is to find what we get when we divide this quantity by 25. And when we divide this by 25, this quantity changes to 101, like this, 0.04. This is what we get. And so the square root of this gives the final value we are looking for. So we now find the square root of 101,04. That is 10. This will give us a value of 10,05. Yes. So the last question was, or the last part of question 5 was a long one, but that's how we get it done. So yeah, that is it for today. Let me record it, and rather let me get the link, then I share with you again in the group. You can find time and watch it some other time later. Otherwise, thanks so much and have a wonderful time. See you again.